Okay, let's take a look at this question, which says, consider a disk with a sector size of 256 bytes, 2,000 tracks per surface, 50 sectors per track, and 5 double-sided platters, and an average seek time of 10 milliseconds. And we're asked, what is the capacity of the track in bytes? So we know the capacity equals to the sector size, which is given to us, which is 256, and then multiply that by the number of sectors per track, which is also given to us, which is 50, and that gives us a capacity of 12,800 bytes. Okay, part B. What is the capacity of each surface? Now we know the capacity, which we will calculate in bytes, is equal to the track capacity, which we just calculated, which is 12,800, multiplied by the number of tracks per surface, which is given to us in the question, which is 2,000. So multiply that. And that will give us a capacity of 25,600,000 bytes. Or we can also say that it is 25,600 kilobytes. Okay, part C. What is the capacity of the disk? So we know the capacity equals to the surface capacity, which we just calculated over here. So let's carry that over, which is 25,600, and then multiply that by the number of double-sided platters, multiplied by 2 because they're double-sided, and this is also going to come from the question, which is given to us right here. So we will have 2 multiplied by this, which is 5, and that gives us a capacity of 256,000 kilobytes. This was in kilobytes. Okay, part D. How many cylinders does the disk have? We know that the number of cylinders equals to the number of tracks per surface, which is also given to us in the question right here. And the answer is going to be 2,000 cylinders. Okay, part E. If the disk platter rotates at 5,400 revolutions per minute, what is the maximum rotational delay? So the maximum rotational delay will be in seconds, which is why we will take 1 divided by the revolutions per minute and multiply that by 60 seconds, which is 1 over 5,400 multiplied by 60, which is approximately 0.011 seconds. And then finally, if 1 track of data can be transferred per revolution, what is the transfer rate? So to calculate that, we will take the track capacity, which we know is 12,800 from part B, and from part A, and then divide that by the rotational delay, which we calculated right here in part E, which is 0.011. And that gives us, and this is in bytes, this is in seconds, so that gives us 1,152,000 bytes per second. And there you go.